Hi everybody, so we're back here. So I did a stream here a few minutes ago. I completely forgot to flip on Twitch's streaming system. And also, I almost forgot about this as well. I have a webcam now. So I picked this up for class, and I know it's maybe the first time most of you are seeing my actual face. You guys can go on GitHub and see it as well. I'm probably going to update my GitHub image with a little nicer image here later. But I got this for class because it's required now for my university work. But I figured, hey, I've got it, so let's go ahead and start using this, and you guys can see my face expressions and my hand gestures as I move around. I know the hand gestures probably won't come through very well because I'm looking over at the camera, and my hands are still a bit low. I mean, we can angle this down a little bit more. That didn't really help. I'll figure the whole webcam thing out later, but I'm going to go leave it up for this video, and if you guys actually like the webcam, I'll leave it on here. If you guys don't like it, I'll turn it off because it can be a little weird to see somebody that you know online actually their face and stuff while they're talking when you're used to interacting with them purely via text and stuff. I know I've got that reaction a few times when I've actually seen some of my colleagues' face. I'm like, oh, that's not at all what I imagined you look like. Anyway, so in the stream today, we worked on EMP some more. We got the EMP gun working a lot better. I switched the EMP gun over to an energy-based system. We built the whole energy-based system and charging mechanics and everything else so the gun can charge and reload and everything. And here, after the stream, I fixed some reload mechanics because there was a bit issue with reload. I fixed some packet problems and et cetera, et cetera. So what we're doing in this video, since it's not designed to just be a reiteration of what I did on the stream, this video is actually designed to be kind of, I don't know, another addition. So I'm going to be making a chat command to recharge items just for testing. Since I do not have an item right now, or I don't have a machine right now to recharge the guns and stuff, but the guns have a charging mechanic for energy now. I need to be able to test that. So it all displays, it says, okay, we have this much energy, how much energy it requires to fire, and it does work. I have tested it, so I know that the mechanics do work, at least mostly. So we're going to spend this video making sure the mechanics fully work, test them all through, and of course build up a little command to recharge items and drain them and do all the cool behavior, so that way I don't have to build a machine, and then I can prototype some of this logic for reuse for the machines later when I finally get the machines up. Actually, I think we might have one or two machines that might work for this. And of course, I am going to have to make machines for this as well later. Another thing with the webcam is you can actually see when I'm taking pauses and drinking out of my water cup. I got like a dozen of these things now. Every time I go to the movies, they give you out those free cups. They're really nice too. They're somewhat dishwasher safe. Unfortunately, they're starting to stain from the dish soap that used on them because they're not actually, at least I don't think it is. They're recyclable, and it does not say they're dishwasher or microwave safe. Really cool cup. It's from the Singed movie, in case anybody caught a glimpse of that. I know the webcam is not the highest detail. It's like a 720p 3 megapixel camera. I picked it up for 20 bucks along with the new chair I bought for $40. So not too expensive. Got to write them both off my taxes because they're work-related expenses. Always a nice thing, being able to write things off work. So yeah, here's the thing, and if we go to fire the gun, we can't even aim the gun right now because it's empty. And of course, it'll try to reload and go, hey, we're going to reload the gun, and it's like, not going to happen. So it didn't find any items. Actually, it didn't even, I kind of failed on some of the data here. So what's supposed to happen is if this goes to reload, and it's not even allowed to reload, but it did reload anyways. So I'm gonna put a break line here. So we click the trigger, and what's supposed to happen is it should have hit that item there. Should hit something. Needs ammo items. Energy is set to false. So what happened? It failed on that. Failed on that little check. I think. Actually, hold on, we can fix this by going gun.doreload equals false. That will fix that little line. So I think the JVM removed this line off for me because it'll do that sometimes. And let me actually put a thing back here. So of course it's going to go through the countdown again, and you're not seeing a message of what it's doing, so you're just seeing the countdown, which is not what's supposed to happen. What's supposed to happen is it's supposed to actually go, hey, you're reloading. There it goes. So yeah, I think the JVM cut that argument out. The JVM will do that occasionally. Actually, no, it didn't cut it out. What happens is that there is there's a separate system here. So there's a reload delay, And then I'll do reload, and I forgot to cancel reload. So that's exactly what was going on. So now every time we click the thing, all we're going to hear is that empty click audio. So that's exactly what I want to hear. Although for this guy, I want to hear like a beam or a charge or some kind of audio noise that makes you think an energy weapon. But we're not going to go dig through audio. But you can see on here, by the way, ignoring all the data because half this data doesn't show up. So the first 5 lines don't show up in normal game. Only the bottom 4 do. So it'll tell you what type of weapon you are, which we're an energy gun. Well, that's actually your ammo type is what that is. Then the ammo we have loaded is an EMP gun ammo. Right now, actually, I think the type is your gun type. Ammo is your ammo type that you can load. And then, of course, we got the rounds. So we got 0 rounds. Each round we want to fire costs 100 watts, and we can store 500 watts of energy, which we have 0 of. So that means we're incapable of firing any rounds whatsoever. So we need a way to recharge this item. So we're going to go ahead and close Minecraft and start working on that. And how this command is going to work is I'm just going to grab the item currently in my hand, and I'm just going to charge it. Real easy. So we wanted to go ahead and do this inside of the core. And there should be, of course, when we go to the core again, we go to commands. And this is technically a debug command, but we're going to make a new package for this, and we're going to call it power. Or energy. Yeah, we'll call it energy. And let's see, we have a debug command. We don't have a debug thing there. So I think how this works is that you can make a subcommand. So we're going to call this power. So it'll be VE power charge item. And then we can say how much energy you want to charge it via. We'll have to actually add this in here. So we'll have to go, I think we just go add command. So come down here. Actually, there's a way to do this. And it's basically we copy this guy. This would be add to power command. And of course, you want to basically change everything in here. So we want to change thread to power. Replace all. So the command name is going to be power, so make a new module command, add that for us. That's how we do the whole command structure. And then what we're going to do is add to power command, new command, charge item. And we'll have to make this, so this will be over here. So command charge item. And this will extend, what do we extend with this? It's been a while since I worked in my case, subcommand. I have this whole command system built up in the Volts engine that is so underused. I need to break it out into its own little package so people can use it basically like Sponge is being used, except not as independent from things. And the name of this command is going to be charge item. Technically what we could do is we can make it go VE power charge and then make another command called item. So that way what we actually, let's do that. So it feels like more like the English language, because then we can go as VE power charge item, full charge item 100, and it feels like you're typing an actual command in. Of course, we want to make sure we actually go get the command types. So it's process entity command. This is going to be an entity only command, and then we're not going to even recognize it as a server command at all. I think people will understand that you have to be entity to charge somebody's item. What we could also do is make console commands for this, but I'm not too interested right now. So the first thing we want to do is go, okay, actually let's go to the debug. Debug's got a full thing right here. And then that way you can just sit here and copy this so I don't have to type everything in. How does debug command? So debug command will actually return true if it's anything else. That makes sense. This is where I pretty much need notes. Okay, so we want to check to see if our first thing is item equals ignore case I don't care. So item is our first thing, so charge item, and then we would have another command called charge machine. And we can actually do a few things with this. So we can make a few words that are acceptable synonyms for this. And if I really wanted to go for, I can even use other languages for this, but right now we're going to do English language because that's all I can really speak. So we're not going to implement this one. So this one we're going to do is we're going to go player.add chat command, new chat command text. And this will be not implemented. Now for our item, what we can also do is we can go, okay, charge held item, or we can just do charge item. So right now I'm going to do a few different, actually I don't know how, so charge item held, charge held item. I'll think of a couple other things for here. So we'll go to do consider making held version and full inventory version. So right now we're just going to do the held version. So we're going to assume that whatever item you're holding. And we're going to go, we want to figure out how much energy you want to charge. So we're going to go, okay, boolean full equals false. And then we go int energy equals 0. So we're going to go, okay, if args.length is greater than 1. So we got to make sure we're actually checking to make sure we have more args. Because what we could do is this, we could assume if you charge item, you need full automatically. So if args.length is not greater than 1, then what we want to do is go full equals true. Then we want to go, okay, if args.1 equals ignore case full, then what we want to do is go, once again, full equals true. Technically what we can also do is we can do a couple more things here, but we're going to just start with full. And then we would go, okay, else try catch. We need to try catch here because we're going to do a number format exception. This is basically anytime if you go to format a number, this is what happens. And you don't want to do anything here other than maybe put a chat message saying you charge value of integer or use the word full for make sure I'm not repeating the same word over and over again. Good idea to make sure when you're writing sentences, especially sentences are next to each other, that you don't use the same word to describe the word. It's just bad practice. And then for this, what we want to do is we're going to go energy equals integer dot parse int. And what we actually could do here is we could also do charge double and everything. Or we could actually do parse double, and it would be the same result. And what we have to do is just floor it real quick or sibling it or do something like that. That way it would work out. There's our energy, and now the next step we want to do is figure out what we're holding. So we're going to go item stack equals player.get held item. So we know what item we got held. First step is we want to go, okay, stack doesn't equal null. So if we're not holding anything, we can't charge anything. And of course, we would put an else statement down here and then tell the player no held item to charge. And this will act as our warning systems and stuff, so that way the player can understand how to use it by simply just doing things. Actually, I'm going to move this one more down. Next step, we want to figure out if we can charge it. So we're going to use the universal energy system. The reason we're going to do this is this makes this work for everything. So if you want to charge up an RF tool, an IC2 tool, it will work, although IC2 support is limited at best and RF support does work, but that needs more testing. So we would go, okay, if universal energy system is handler, pass in the stack, and we don't really care for a direction because items don't have size. And that'll tell us if we're in a handler. If else, we want to go, okay, held item is not supported for energy-based charging. If this is a mistake, report, make mistake, make an issue we want to go ahead and supply basically the volts engine project. I feel like it's going to be a dumb idea to just point them directly to this spot, but make an issue to this link asking for support to be added. I don't remember if it will automatically convert the link for me, but I'll hope it does here later. Anyway, so if we is handler, then what we want to do is we want to figure out how much energy. So if we know how much energy we have, so if we go with energy does not equal 0. And what we also want to do is we go, okay, if energy is less than or equal to 0, return. We also want to return here. True. True. Anytime we have an error, we want to go ahead and return, so we don't sift all the way through, because we want to cancel any further actions here. We want to go ahead and put in a thing here going energy value must be greater than 0. Here we go. So we go that, and we go like else if energy, or else if full, we do actions. And we go. We also want to do the further action. And this will be missing energy though. Unix error failed to select charge type of energy value for full. This is just for debug. With logical error, not user. That way they know it's not their fault. So that means there's a bug. Fail to select charging type is a logical error. And not a user error. There we go. So that'll give us information. And then we want to, let's see. Basically, when it comes to charging, we literally just call the universal energy system. And we go fill, and we pass in the stack. And fortunately, I have a phone call here, so give me 1 second. Okay, so yeah, that was just the vet calling me to let me know that my brother's cat's meds have shown up. So we want to pass in null, energy, and then true, because we don't really care to test to see if it can take the energy, we just want to try to give it energy. And it'll tell us how much energy is put in there, it's the amount of energy received. So we're going to go double in the energy. And the reason this is a double where our energy system is an integer based is because there's conversion ratio problems and stuff. So you want to make sure you kind of convert. So we received. Okay. And that'll tell us how much we received, so we can then go tell the player, go, hey, here's how much power was put into the machine. Or rather, device. Item charged with technically, I want to change this, that if this is 1, it goes 1 watt of energy. Because you can say 0 watts, but then if you say 1 watts, it sounds weird. 2 watts sounds fine, but you want to say 1 watt if it's technically 1. Hard to say that. Actually, you want to cast this command. So that way it's received. And then what we can do is go, okay, if received equals 1, and we do like a little bit a different wording here. That way my sanity is a little better. And then when it comes to fully charging, it's a little different mechanic. So actually what we want to do here is we're going to remove this, get rid of that, put this up here. So if we want to fully charge it, and we are an energy receiver. Basically how this works is energy will equal universal energy system dot get capacity. Get energy, get max energy, there we go. And we pass in stack everything. And that should do the trick. Why? Okay, it's a double, found double required int. Okay. Okay, so the math was the math.ceiling. There we go, because that'll work. So I don't really care if it's precise, it just needs to be, we're going to put it to ceiling so it's 1 more watt than may be required. And this whole system should work. Now we just got to make sure the command actually gets imported, and we should now see a new command. And when we start the game up, we should be able to charge the item. And then as soon as I'm done with this, I get to go drive about an hour to another town to pick up meds for my brother's cat. This cat's got like, I think it's bronchitis. They didn't really explain it properly, but ever since my brother adopted the cat's had breathing problems and stuff, and we thought we had taken care of it originally, but the cat's always been this bit moped around a little bit every so often. We'd do this thing like where she chicken-legged, where her legs would be sticking out on her sides, and she would try to get her head as low as possible. And according to what my brothers told me, that's a sign that they're having breathing problems, so we took her to the vet along with my dog, because my dog needed to go to the vet as well, which was nice because we got a discount for taking both at the same time. But they did x-rays and a whole bunch of stuff and found out that she has like bronchitis or something. Which I gotta check what meds, because I think they said they might be giving her penicillin. I'm allergic to that, so we're gonna have a fun time of figuring out how I'm gonna transport that without having an allergic reaction. That's gonna be an interesting. Hopefully they got it in a container and it's been pre-sealed and not contaminated on the outside of it. Because that's the main concern, is that like during packaging, it might have got some on the outside, and if I touch it, then I'm gonna have fun. Good thing is I have a cell phone, so speaking of which, we should probably charge this thing. I always forget to charge my cell phone. That has got me some pretty crappy situations too. Like I forgot to charge it one time, and I was trying to get back from work, and I took a wrong turn, and I was like, oh well, crap, I don't know where I'm going. And I ended up taking an extra hour to get home because I went up some side paths and got lost, and fun times. Luckily, I remembered a nice tip my brother and my dad taught me. Every road leads back to 22, so if you can find 22, you can find your way home. And it works. It actually does. So our item is not charged. So now what we should do is UV power charge item full. The item is not supported if this is a mistake, an issue, making I uber failed on typing there. Also didn't do the link properly. I think there's like a way you have to do links. I'll have to look it up later. So this is a mistake. Make an issue at asking for support to be added. And what I want to do is replace it with a GitHub button. Is what I want to replace it with. So it did recognize our item as an energy item. And this actually, I think I know what's actually wrong with this. The system does not understand how to identify the power system because I just finished it for items. So I need to go, I'm just going to put a break line here. And actually that won't work. I need to find the energy handler class. So I don't want to just like cheese this and just add handling right here, because the whole system is designed to register handlers. So there's an IC2 handler and there's an RF handler. Where's the UE handler? Is there just not one in here? It'd be kind of stupid if I don't have a handler for my own stuff. It won't be the first time I've done that though. It's weird that there's not one registered. So there's not one. I'm gonna have to make one. That is, I feel kind of stupid now, because that's something that should have been in here from the start, and it's not. So what you would actually have in here is like something like this. So I don't even have support for my own mods. Implement methods. Oh, fun! I'm missing everything. It's a 1-to-1. Actually, this is so the ratio is a 1 because we're doing our own thing. It's watts, full unit. I'm lazy. I'm not going to do that. String name. So modular name is UE. So we got all our stuff there. Then we just kind of want to, wow, do a lot of checks here. So this is actually supposed to call do is handler object, and this is supposed to return if object instance item stack item equals object.get item. Actually, this is an easier way to do this. Return do is handler item. That way we don't have to write the code twice. Else if object instance item return if object, which we're going to have to actually just do it that way because we don't have to cast it. We just have to just go with objects instance of this. And then else if object is instance of tile. Actually, no, we don't care. If it's anything else, then it should be an instance of one of the other systems. So if object is instance of high energy buffer provider, that's the only other system there actually is a handler for. Do is energy container. Once again, this is going to be this down here. And then if we get these guys, then the only way it's an energy container is if it's a buffer item. Because energy container is different than just a normal charge item. If can connect, if, oh, well, this is going to be interesting. So if object is instance of iConnector, iTile connection. I have a thing for iEnergy connection too. What is iEnergy connection? Oh, that's from the CFH API. Okay. So iTile connection is one of my classes. And then we want connection type. And then it's going to want to know a lot about the data. Return object.canConnect source, I think, as connection. Source is instance of tile entity. Then we want to use source. If not, we're going to pass it null if it won't work properly. And let me make sure we cast this guy. Then I believe it's direction. And then we want a connection type actually as well. Incompatible. I have to cast the type too. That occasionally happens. We want our types to be connection type.power. So we don't know what type of power it is. It's just its power is what we're receiving, and that'll work. Actually, if it's anything else, you just want to capture. There's no handler. Get item with charge. So what this will be is if item stack dot get item instance of energy item, then we just want to basically call. Actually, how does this method work? So get item charge. Do we want to charge this item, or do we want to make a copy of this item? I'm going to assume we just want to charge this item, and I'll fix it if it breaks later. So this means we want to call item stack dot get item dot recharge item stack energy. Let me make it true. Of course, this is going to be math.floor. This will be math.save because we want to make sure it's giving it the most energy it can. Oh no, we want to floor this because that could be an exploit that somebody could exploit. So we need to floor. So there'll be a small energy loss if there's a conversion problem, which is not going to be a conversion problem. And then you just want to return item stack. I do need to check what this is. Please tell me you're documented. Oh, you're not documented. It's a super old system. Get energy. Repeat this whole system over again, except this is going to be, oh, this is different. So we want to actually, yeah, we'll have to do 2 checks here. So we're going to have to go if object instance of item stack and get item is instance of I energy buffer item. Then you basically just want to return object.getItem.get energy pretty much, and we pass an object. Of course, that needs to be casted. The other alternative for this is going else if object is instance of energy buffer provider. Then you want energy buffer equals object.get energy buffer for side. I don't know if I need to reverse that side. That's something we have to check. If buffer does not equal null, because you can have null buffers on sides. That's the reason you can do the whole get buffer per side. Is the ideal is if you want to limit your capacity or anything, you do it by passing back a restricted buffer, which we do have on a couple of tiles. And you would do buffer.get energy stored. And then max energy would be pretty much the same process here. So put it down here, and instead of change that real quick, so I don't have to deal with that. This will be get capacity. Now I want capacity. Get max buffer size. I need to keep consistent with this. Get energy item. Get max energy item. So I'm actually just going to do this by being lazy. So get energy. This will be is null. This will be get max energy is null. And clear energy would be pretty much. We actually have 2 options on this one. There's actually a couple options on this one. So the first one we want to try is we just want to check these 2 guys if they're basically the same. And then we want to, if it's a buffer provider, we literally can just set energy object and then 0. Cast that, and there's this, you can do the same exact thing to this guy down here. And there's apparently no return on that. I'm going to just return. Apparently, I need to log how much energy is in there. So double energy equals. I'm not going to call get energy on that. I'm going to just not be lazy today. So we're going to grab this guy. So double E equals this. Return them. The sad thing is I used to have handlers for all this stuff, and I think what happened is they got deleted because I was just like, they're not working. Best not waste a bunch of time just sitting here looking at code that probably isn't going to work. This actually needs to be 1,000. So this will be actually does this, if I call set energy on this, does this do that thing? Set energy and 0. So we want to make sure we do the previous thing as well here. So this will be return E. This will be buffer.get energy stored. I could actually change the API if I wanted to for this, but I'm not gonna. Oh. Oh, that's gonna be fun. So let's do this. Equals 0. Forge direction, forge direction, out directions. I believe the clear energy code is only used by the EMP, by the way. So what we do here is E plus equals this, and then we want to return E at the very end. So the likelihood is you're only going to have one buffer per machine anyways. It's going to all be internalized, so it doesn't matter what side you call, it's going to clear out. But forward direction. Actually, I got a better idea. Theoretically, what is supposed to happen when this actually gets run, and I'm going to clean this up because this is actually let's do Control-C, because that'll get me back to where I was before this. I was about to do this the way I did, how I had to fix RF energy, because RF energy's got the stupid problem with it too. But we can do this. Forward direction unknown. And let me change this here. So null should be treated as forward direction unknown. Access provider unknown should return the internal buffer. Here we go. And we're getting there. And my dog is whining at me. Every time I make a video, she doesn't. And the sad thing, she want to go outside right now, but it's raining. And I've let her out like 3 or 4 times a day. And she goes out and it's like, oh, it's raining. And then stares at me like, can you change the weather, please? I'm like, I may be good, but I'm not that good. So I'll take a pause here and I'll be right back. I don't really get my dog here. She barks at me, getting my attention. As soon as she gets my attention, she walks to sitting right in front of the kitchen and just sits there and stares at her bowl. So she's been fed twice today now. She doesn't get fed again until I eat dinner, and she's, I guess, trying to get more food. Either way, I threw her a chew toy at her, so she's a little happy. So we want to charge items, and yeah, so we basically want to set up our system here. Okay, so where were we at? I think we got this guy here. So we have actually, let's do this. Let's do this just from scratch. So item stack, get item is instance of I, energy item. So we want to try to do the charge system first, and then we can fall back to if else if item stack get item is instance of I energy buffer item, which is the other option we can do. This one's pretty much going to be pretty much go int room left equals item stack get item get energy capacity item stack minus item get item get energy set energy. So that'll get us how much room we have left. And essentially what you would do is you go, okay, if joules is greater than equal to room left, then you would go, yeah, let's see this real quick. So int e equals this. So we want to record how much energy we have, because you're going to have to do call item stack dot get item dot set energy item stack e plus room left, and then you want to return room left. And of course we have to do the do discharge thing, which I have to go through and make sure I did that with everything, because the reality of it is I may have screwed up. So do discharge. Actually, I just wrote the mechanics for charging it. Let's go put this up here. Mistakes were made. So if we're discharging, so the discharging mechanics is a lot different. We don't really care about this, and we definitely don't care about capacity. So we're just simply going to go with joules greater than room left. We then want to return E, which is how much energy we have, and we want to set our energy to 0. The other alternative is if the joules is less than, we want to return joules, which is how much energy we actually wanted to pull out of it. And then we want to set our energy to E minus joules. And of course, this would be math dot floor actually I gotta do something. So int new energy math.floor. There's a little bit of conversion work that has to be done here to make it kind of not result in energy loss. So int added equals new energy. Oh wait, it's E minus new energy, because that's how you get the actual difference. And then we want to return added. So that way we don't end up with a rounding error that causes you to lose energy that you... So what would end up happening is if you were charging something and it had like 1 joule space left, but then you were trying to put 0.25 joules of energy in it, that 0.25 would disappear if we didn't do things correctly. Because it would go, yeah, we can put energy in here, and then you go to put it in here and it would round it down to 0, and the energy just vanishes. So we don't want that to happen. So how you want to do is you want to floor it, and you want to go, okay, yeah, sure, let me refactor that so I can type it in correctly. So that way it'll go, okay, we're going to, if this was 0.25, you would actually end up a proper number. And this is the discharge code. I was talking about charging code, but it's the same idea. You don't want to end up with rounding errors. So yeah, this would come up here. So this is else. So if we had that the joules was less than the room left, this is where that comes into play. So you want to go int new energy equals E plus joules. And this is where we also then go, I don't even know why you popped up. And then we go int. Let me rename this too, because this is misleading. So we int added equals, and in this case, new energy is going to be greater than energy, so that's why we want to minus it by the previous. And that gives us how much we have added, so we're going to go return added. And then, of course, if we're going to do the charge, then we would actually call our set energy method here with the new energy value. There we go. And that handles energy buffer items, but now we have charging items to handle. Now, the cool thing about a charging item is it handles its own code, so all you have to do is pretty much redo this. Return, actually I'm going to go int floor equals math.floor joules. Because we're going to have to go ahead and floor that before we pass it into our charge method. And then we just go return item stack get item dot recharge item. Now let me check the method signature on this. This is stack energy then do charge. So basically the same thing we have up here. The only difference is we rounded down the number before we pass it in. Basically the same thing's going to happen over here, except instead of calling charge, you're calling discharge, and the item handles its own mechanics. There we go. And that fills out that entire class. That wasn't much work. I mean, I think we only took about 15 minutes to do this whole thing. Of course, we got to do this for machines. It's weird when you think about it, is that the machines theoretically should have handling for themselves, but they don't. And I feel like I've already coded this entire system. I feel like there's already a building mechanic for this entire system. But when you sit here and you look at it, I don't see it. It's all based off the energy handler. I think some of the machines just have built-in handling for UE machines by default, and that's what we don't want. We don't want to have that situation. We want to make all the machines run through the same code section, so that way they're not doing special case handling. Although this will end up in weird results, like if UEs are prioritized, so if it isn't at the top of the list, and you went to go look at a UE machine, all of a sudden you could hit RF code, and it would be using RF code to power everything, which I'm not against, but if it's a UE machine, I'd rather you're going to be running UE code by default. This stuff is pretty simple though. I'm just going to go ahead and do it. So we want to go, okay, if if handler is an instance of item stack, we want to make sure it actually does the correct thing. So I don't think this will ever happen, but we want to make sure that if for some stupidity reason we end up in the wrong method, because let's say somebody was running our API and did not do what they were supposed to do, then we want to make sure the code runs as anticipated. Make sure we put this down here as well. So I think there's a couple places where this code is a little. Think of it like a legacy code more than anything, because the charge item stuff is a newer addition. So this would be discharge item. So I believe the charge item and discharge item are only used by inventory slots to discharge stuff. Anyways, else if handler is instance of I energy buffer provider. And basically we want to run the same code down here. So for extracting energy. Actually, no wait, the energy buffers have their own handlers. So I think it's handler dot receive energy. Oh wait, no, actually I'm thinking of it wrong. This is what we're looking for. Energy buffer equals handler dot get energy buffer direction. And then if buffer doesn't equal null, return buffer dot remove energy. And this is where we have to floor it too, so we don't have to do this thing. Floor energy, floor, and then do extract. So that's handle. And then we basically do the same thing up here, except instead of extracting energy, we're receiving energy. So this would be add energy. And this would be to receive. Cool, so that's completely utterly set up. It's not tested, so we're gonna have to test it as we go. But it's pretty basic code. It's not very complicated. This is if you ever wanted to implement your own energy system for compatibility with Volt's engine. I don't have to add support for your system. You can literally go in, make a handler like this, and then register it in the universal energy system. Set up your ratio, which can be configured based. Of course, we're going to set this to 1 because it's 1-to-1 with UV, so there's no conversions. And that should work. So now if I save and quit and reload, we should be able to restart and do the thing. It was a little dry after that. I forgot I had music. I don't even remember if I turned this on at the beginning of the, I don't think it's been on this whole time. We'll go ahead and leave it up though. Because it can be pretty boring just sitting here watching me. At least you guys can listen to music while you're doing it. What we got here? So we're working on Volt's engine right now. Make sure I pop this up so I can sync commands here. There's the packet handler I was working on earlier. Oh wait, that's the no, that is the right one. I'm looking at the wrong stuff here. So edit error handling for rare empty packet issues. So there's like this rare packet issue that's going on that I still haven't figured out what's up with it. But the player went null in the middle of the packet, and that should never happen, ever. So go ahead and load this up. I'll have to run out of time here too. I told my buddy Grogger here I'll be done here by 4. So we got 4 minutes to figure out if we made this command work or not. Although I'll deal with his wrath if I'm a little late. That's just top of my head is like off the webcam. Need to like really work on the camera placement. So VE power item, no, VE charge item 4. Okay. That looks like a bug. Probably in my typing. So there's debug item, this charge item. Oh, no, that's correct. So actually, should be created in 0. So it's identifying as a handler, so it's working. So is full is true. Energy is still 0. So this is our bug problem right here. it couldn't figure out what handler it was. Is handler. Wait, what is this thing? Go away. Go. Try this again. So we know the is handler check should be working. Yeah, so returns true. I just messed up on that. Oh, I see what's wrong here. So what we want to do is go if handler is instance of item stack. Actually, we can solve this by doing this. Then breaking it down to this. We'll clean it up a little bit more, and this needs to be replaced with a get call. Here we go. So that's what's preventing it from identifying the handler correctly. I mean, we have like almost no item supports. This explains why a lot of this is happening. The only thing we really had support for prior to this was machines. So hit peg again. Did we get energy? Yep, it found 500 energy. That's exactly what should be in the item. Received 25 energy, because yeah, there's a limit on how far the energy can be received. I regret that. I really do. We can solve this though, but it does prove it does work. So all we need to do is call this like a couple times, and we should be able to fire the weapon. 125. It's not detecting the 100-watt balancing. It could be a rounding error. Did you seriously fire without firing the weapon? Oh. Okay. The command works. I'll fix the bugs in the energy code later, so I'll close this video off, and I'll see you guys another day. And if you kind of like the webcam thing, make sure you comment. If you don't like the formatting of anything else, make sure you comment. If you like the video, hit the like button. If you want to see more, subscribe, etc., etc. You know the normal stuff after the end of each video. But see ya.